Alright guys, CP here and Happy New Year. Here's to hoping 2021 doesn't make 2020 feel like 2019. Anyway, today we're talking about Apple's new M1 MacBooks and how the new ARM architecture might affect computer science majors like me, or like you. So I've got an M1 MacBook Air here, and the plan is to see the tools that we use in our computer science classes can actually work properly under this new architecture on this new machine. Because I go to USC, if you haven't heard, because I go to USC, I'll be sticking to USC's computer science curriculum and all the required classes that you have to take. Before we jump into the actual courses though, I like to take a moment and install Homebrew. Think of it as a command line app store for developer tools such as Java, Python, or Tomcat. To install Homebrew, visit its official website and paste the installation command into the terminal. However, if you open up terminal directly and try to install, you will run into this error. This is because the official release of Homebrew does not yet support ARM processors. To fix this, we need to run terminal under Rosetta. Open up Finder and navigate to the Utilities folder in the Applications folder. Select terminal and use Command D to duplicate it. This will be our dedicated x86 terminal that runs under Rosetta. Right-click on the new terminal and select Get Info. Then check Open using Rosetta. Now, if we try to install Homebrew under our x86 terminal, it will proceed as normal. If it prompts you to install Xcode command line tools, go ahead and do it. Now we have successfully installed the x86 Homebrew on our ARM Mac. We can verify that it is properly installed by calling brew. Now let's move on to the actual courses. First, let's check out CSCI 104. Now 104 is our Data Structures and Algorithms class. The main things that we need are Docker or a virtualized Ubuntu, so Ubuntu in the VM, C-Line as the IDE, and VS Code, Visual Studio Code as the code editor. C-Line and Visual Studio Code are not actually required. I just personally think they're really useful. But again, as the head CP, my opinions are always objectively correct. So, VS Code is superior than Sublime Text. That's it. It's settled. I said it, so it is a fact. Anyhow, let's dive in. Docker already has an Apple M1 technical preview available to the public. Install it and follow the instructions on the CS104 GitHub. The script will download and build an ARM version of Ubuntu with all the necessary tools you'll need for the class, such as Valgrind. After the installation script finishes, you can run the manager script to start the VM and mount a directory of your choice for direct access within the VM. For simplicity, I mounted my home directory. To test if this really worked, I downloaded one of my 104 assignments from 2 years ago. It is a local markdown file search engine with Google's PageRank algorithm. I had to add in some printouts because the program would only silently fail. After that, I attempted to compile and run the program. It successfully compiled and ran without any issues. Next, we took a look at JetBrains C-Line, which is my go-to IDE for C++ development. In my opinion, JetBrains makes some of the best IDEs for a wide range of languages, and you can obtain a free student license that gives you full access to all of their products. C-Line does not run natively yet, but works fine under Rosetta. It may seem a bit laggy here because I was launching it for the very first time. I built and ran the Hello World program, and it all went smoothly. Finally, let's take a look at Visual Studio Code, one of the top code editors and can even double as a lightweight IDE with its powerful plugin system. It currently has an insider build that runs natively on the M1, but here I downloaded the release version. Nonetheless, it ran perfectly under Rosetta. Later, I tried the ARM insider build and it felt much snappier than the Rosetta build. Not that the Rosetta build ran slowly at all. It may seem a bit slow because again I was launching it for the very first time. Now let's move on to EE109. Now EE109 is the introductory electrical engineering course. However, all CS majors are required to take it. The class revolves around building circuits and eventually graduating onto more complex final projects, such as a laser rangefinder or, in the case of what I did, a thermometer. But of course, to build those more complex projects, you need to make use of an Arduino board. Now, an Arduino board is basically a small board that's kind of this big, I think. And what it does is that you're able to write C code, and it is actually able to execute it and manipulate the circuit as you wish. Now, in order to program it and upload the C code, we need two things. We need the Arduino IDE, and we also need something called the AVR toolchain for the upload. The Arduino IDE is very straightforward to install and appears to work well under Rosetta 2. However, because I don't have my Arduino board on hand, I couldn't test if the IDE would communicate with the hardware. I suspect it would work though, seeing the IDE correctly identified my MacBook's various ports. For the AVR toolchain and the rest of the setup, there really wasn't that much to talk about. I followed the write-up on E109's website and everything went smoothly. Now let's move on to CSCI 201, Principles of Software Development, or Engineering, or something, which is my home turf, so I should know the name. The whole reason I became a SCP is because of Jeff Miller. 201 is when Jeff Miller took me in as a CP, when I only scored an A- on his final exam. Instead of reinventing the wheel with data structures or trying to prove P equals NP in your algorithms class, what you're expected to do in 201 is a little bit different. In 201, you're given a project that's basically a requirement spec sheet, and you're expected to build a project that satisfies those requirements. Now for 201, we need three things. First, the Java development kit, because most of the projects will be written in Java. And second, we need a Tomcat web server. So because some of the projects involve a tiny bit of web front end, or actually some web front end, I won't lie. So you need a server to host your website locally. And the third thing that you need, of course, is an IDE, because look, we're professionals here, all right? We don't use Vim. We're in a professional environment. We care about, we don't care if you're some pro hacker. All we need is to get things done quickly. And unless you're a Vim master, which, let's be honest, most of us aren't, an IDE can help you immensely during your development. Now, the officially supported IDE is Eclipse, although you can also use IntelliJ. Now, I agree that IntelliJ is a lot more superior to Eclipse, but the setup is really different, and the file that it exports is also different. Now, the class doesn't officially support it, and so if you want to use it, do it at your own risk. So always test out your IntelliJ project in Eclipse before submitting, so you don't get any headaches and zeros. First, let's install OpenJDK. Thanks to Homebrew, the entire process is trivially easy. Type in brew install OpenJDK and you're set. You can type in brew ls OpenJDK to see its local path. Moving on to Eclipse and Tomcat. Installing Eclipse is very straightforward. Simply download the latest installer from the official website and follow the steps. It might take a long time though, depending on how slow the servers are. When you're done, launch Eclipse. As you can see, Eclipse works perfectly under Rosetta 2, and I was able to get a Hello World program going in no time. Now it's time to install Tomcat. Go to Help, Install New Software, and choose to work with the latest release. Then scroll to the bottom and check Web XML Java EE. This installs the necessary web components for Eclipse to interface with Tomcat. At the same time, open up an x86 terminal and do brew install Tomcat. Then use brew ls Tomcat to get its local path. After Eclipse restarts, go ahead and create a dynamic web project. In the pop-up window, click New Runtime and select Apache Tomcat 9.0 in the list. Paste in Tomcat's local path that ends with the folder libexec and click Finish. Make sure to switch to the EE perspective. Now create a new HTML file in Web Content folder and name it index.html. Look for the server tab at the bottom and click the link to create a new server. Make sure Apache Tomcat 9.0 is selected and click finish. Right-click index.html and select Run As, Run on Server. If you see a web page show up without any errors, then we're done. IntelliJ is not officially supported by the class, but in my and many other developers' opinion, it is vastly superior to Eclipse. Since it shares a base with CLion, it works just as well under Rosetta 2. Alright, moving on to CSCI 310. Now 310 is the software engineering class at USC. Stop telling me to stand. Anyhow, in 310 you spend an entire semester working on a single project, and it's often very document heavy. Now depending on what professor you get, you might have to do different things, but from what I've heard, Android Studio seems to be a norm, so let's test it out. Since Android Studio is basically Google's fork of IntelliJ, the IDE itself works just fine under Rosetta 2. However, there is a problem with Android Emulator. The emulator takes advantage of Intel's VTX and HAXM technology, which is essentially a form of hardware acceleration for virtualization. It doesn't work on the M1 for obvious reasons, and as a result, the emulator that Android Studio downloads will not work. Don't worry though, as there are two workarounds. First, if you plug in any Android device and run your program on that physical device, it will work without any issues. Second, Google has already put out previews of Android emulator that support Apple Silicon. Make sure you download the latest build, which is v.3 when this video is being made instead of v.1, which is extremely bare bones and doesn't even come with the Google framework. In my experience, the M1 Android emulator is extremely smooth, even more so than Apple's very own iOS simulator. As you can see here, my app Q builds just fine and is buttery smooth on the M1 Android emulator. In conclusion, unless you need your app to run on a specific device, there's no problem doing Android development and taking 310 with the M1. Moving on to CSCI 350. CSCI 350 is the operating systems course. It involves modifying a simplified Unix system called XV6. To add functionalities such as Geez, I just took this class last semester. Some kind of scheduling algorithm, some kind of memory management, some kind of file system. Now, that's all fine, you write all of those in C, but the problem is, the XV6 system is compiled for x86 processors. And as far as I know, and as far as anyone knows, there really isn't a way at this moment to emulate a whole different architecture on a different architecture. So there's no way to emulate an x86 system on an M1 chip. If you're running an x86 Mac and you're doing mobile development, you might be thinking, okay, well, I have Android emulator and iOS simulator running. These are obviously mobile ARM operating systems, and how is it being emulated on my x86 Mac? Well, the answer is they're not being emulated. The Android emulator and the iOS simulator that you run on x86 machines, they're actually an x86 build of Android and an x86 build of iOS. So the more you know. Now you might remember if you saw Apple's big reveal event for the M1 MacBooks that it was running some kind of VM and running Windows 10, but the thing is, you have to realize they're actually running an ARM build of Windows 10, not an x86 build. But an XV6, it's literally compiled for x86. So I think if you're going to take 350, maybe don't buy this laptop, don't switch over just yet. But if you have money, just have two laptops. Moving on to CSCI 356, Intro to Computer Architecture. Now in this class, we learn about assembly code and some of the other more low-level program routines. And let me just tell you right here that it doesn't work. Mainly because assembly code differs wildly between different architectures, and all the assembly code that you learn and make and compile, modify, they're all under x86. Now, in a lot of assignments, you're given compiled executables and you're supposed to use the GDB debugger to debug them and step through the instructions. But the problem is, it doesn't even run under Rosetta. So if you're going to take this class, then I would suggest skipping this machine for now. Alright, moving on to CSCI 360, which is Intro to Artificial Intelligence. The one class that I hated more than 104. Now this class usually involves coding up neural networks and algorithms in C++, and then using the provided Python driver to test out your C++ code. So let's test out C++ in Python. Since we already established C-Line works, I wanted to try and run some of the projects. First, I tried running a C++ neural network that identifies handwritten digits, and there was no problem. Then, I tried to test Python by running a Markov decision process project. Compiling the C++ code went smoothly. However, when I attempted to run the Python driver, NumPy kept giving me an error saying my macOS version is incorrect. Since Python already has a working ARM build, this is most likely a bug in NumPy that needs to be fixed. Nice. We just went through all the CS classes at USC and tested out if they work with the new M1 MacBook over here. Another tip when purchasing Apple devices in general is to use your education store. So the education store usually gives you a discount of around $100, and that's not bad. So that's it for today, and thanks for watching. See you guys next time.